This is Food Chemistry Unit 2, Basic Food Chemistry, the Nature of Matter. So a good definition of chemistry is that it is the study of the makeup, structure, and properties of substances and the changes that occur. Chemistry is necessary to understand why ingredients in food react the way they do. So to understand chemistry, we need to understand matter. And matter is anything that occupies space and has mass, like food. Basic nature of matter. So all matter is made of atoms, which are the smallest units of any substance. The atom itself is composed of subatomic particles, or smaller particles. The center of the atom is the nucleus. You can see that here in this great depiction of the atom. Here's the nucleus. The nucleus contains protons and neutrons. Protons have a positive charge, and neutrons have no charge or are neutral. And you can see the protons and neutrons in the center. Electrons are found in orbitals around the nucleus and have a negative charge. And electrons are much smaller than protons and neutrons. And here you can see the electrons. Now this video right here, Dogs Teaching Chemistry, is super cute, and it's a nice little refresher about the structure of the atom. Now atoms make up elements. Each element is composed of only one type of atom. There's roughly 90 naturally occurring elements. The rest are synthetic or created in a laboratory. Now elements are arranged on the periodic table by their atomic number, which is a whole number. So that atomic number is the number of protons in the nucleus of an atom of that element. That's the identity of the element. It's based on the number of protons or the atomic number. Now, Dmitry Mendeleev organized the table by properties. Elements were placed into groups based on properties. So groups are the vertical columns that are numbered and named. Periods are the horizontal rows, which are numbered. And then we also have a mass number. This is the mass of the protons and neutrons in the nucleus, which is also included on the periodic table. And you will see these as a decimal. So you can see this is a little piece in the periodic table. So each element is put into its own box. You'll see a symbol. The whole number is the atomic number, and this decimal number is the mass number. Now this is the periodic table I like to give to chemistry students, and you can also access it online. This is a great periodic table that shows the groups that we were just talking about. So if you look at the top, you can see 1 to 18, and these vertical columns right underneath. Those are the groups. And a lot of them have names. And you can see in this periodic table, it's color-coded. So this blue group right here, these are the noble gases. And they're all in this group with similar characteristics and properties. That's how Mendeleev organized this table. So when you see these groups, all elements in that group share similar characteristics. If you look at this orange group right here, right? This is the alkali metals, with the exception of hydrogen, and we'll talk about why that's an exception in just a second. But these alkali metals would all share similar characteristics. So these are groups. Now the periods are simply numbered. So it's the horizontal rows, and there's 7 of them. And now as you look at a box for any element, let's take sodium, right? So that Na is the symbol, that 11, that whole number is the atomic number, the number of protons, or also the number of electrons, because atoms are neutral, so your protons and electrons would be the same. And then this decimal number is the atomic mass. Now the reason it's a decimal is that it's an average of all versions of sodium that exist, because there are some versions that could be radioactive. Okay. There's also another periodic table that I like to give to food chemistry students, and it's this one, because for each element, it shows you a use for that element. So you can see, like for potassium, right, it's found in fruits and vegetables. So this is a great periodic table that you will have access to as well. Now the periodic table is broken by the staircase, which separates the metals from the nonmetals. Metals are on the left of the staircase, and nonmetals are on the right of the staircase, with one exception: hydrogen. Hydrogen is the first element in the top left corner due to its size. Now, elements on the staircase have metallic and non-metallic properties and are known as metalloids. So here is the staircase, right? You can kind of see it. It's this kind of a dullish green color. These are your metalloids. So they have characteristics of metals and non-metals. Now, to the right are non-metals, and to the left are metals. So you can see that the majority of the table are metals. There's a huge amount of metals compared to your non-metals. Now, metals conduct heat and electricity, can be drawn into wires, and can be pounded into sheets like aluminum foil or copper. You can use a lot of copper like cookware. Gold is a lot of jewelry, so you can get different shapes or sheets out of those. And metals are usually a solid, but mercury, for example, is a liquid. Now, non-metals are poor conductors of heat and electricity. They're brittle if a solid, but can be liquid or gas. And examples include oxygen, chlorine, and carbon. Those are non-metals. Now, here's another great video that will be posted along with my dogs in chemistry. These are posted just for your reference if you'd like to watch them. It's not mandatory, but they're great videos. So this is from ASAP Science, and it runs through the entire periodic table. You'll learn how each element is pronounced, and then you'll see a use for each one as well. Compounds and chemical formulas. So now that we've looked at elements, you can put elements together to make compounds. So two elements combine to make a compound, sometimes called a molecule, which has properties unlike the original two elements. So for example, if you took sodium, which is Na, that's a solid, and added that to chlorine, chlorine is a gas, you would make sodium chloride, which is salt. And salt, as you know it, is a solid, right? Because you put it in your foods. Now, how do you get a solid and a gas making that solid sodium chloride? So that sodium chloride is now quite different from the two elements that you started with. So that's the beauty of chemistry, right? You can put elements together and get a new product. Now, if you'd like to actually see how this is done, I will post this video as well. So this is the formation of sodium chloride or salt from these two elements. Now, chemical formulas are combinations of symbols of elements in a compound. It represents one molecule of a compound. Now, knowing how to read chemical formulas helps you understand products and ingredients. Subscripts, or small numbers in formulas, indicate how many atoms of each element are in the compound. So the first skill that I will ask you to complete is knowing how to count your atoms in a formula. So look at H2O, which is water, right? So you have 2 atoms of hydrogen for every 1 atom of oxygen. So that's a total of 3 atoms in that molecule of water. 2 H's plus 1 O gets you 3 total atoms. So now what I'd like you to do is try my next 2 examples. I will reveal the answers, but see if you can figure these out before I show them to you. So what if I asked you how many atoms are in CH3COOH? Or how many atoms are in MgNO3 2? So what you need to do is count your individual atoms and then add them up. But now be careful with the MgNO3 2 because you have that parentheses. So let's see if you know how to answer this now. So how many atoms are in CH3COOH? Well, what you do is you just count up your atoms. So carbon is the letter C, and I have 2 of them. H is hydrogen, and there's a total of 4, right? 3 here and 1 here. And then oxygen, I have a total of 2. So 2 plus 4 plus 2 makes 8 total atoms. Now how about MgNO3 2? So Mg, I have 1. Now I have nitrogen, which is in a parentheses, and there's a 2 on the outside. So this 2 distributes, which means you multiply it by each of the elements in the parentheses. So this is not distributed to the Mg, just to what's in the parentheses. So nitrogens, I have 2. And then oxygen, so I have 3, and there's 2 on the outside, so that's 3 times 2 makes 6. So that's why this nitrogen was only 2. It's not the fact that I'm just calling it 2, right? There was 1 nitrogen here, you didn't see it, but that means there's 1. So 1 times 2 is 2. So if you add these up, 1 plus 2 plus 6 makes 9.